Welcome to the last video lecture on Chapter 5. Here we'll take a look at some applications of circular motion. A satellite is an excellent example of an object in circular motion. It travels at some constant velocity, v, and which is always going to be perpendicular to the gravitational force that is providing the centripetal acceleration. The gravitational force is due to the Earth's mass and the satellite's mass. The velocity is always tangential to the circle, and with the acceleration due to the force of gravity, the centripetal acceleration, it changes that velocity just a little bit. In reality, what's happening is the satellite itself is falling down to Earth, but because it has some perpendicular velocity, it keeps moving along in a circular path. We'll revisit this in a second. The centripetal force acting on a satellite in orbit is due to its weight, or force due to gravity. Because of this, we know that there is only going to be one speed that a satellite at a given altitude can orbit at. So if we were to set our equations equal, the weight is equal to the centripetal force, substituting in our different values. M2 would be the mass of the satellite. They would cancel out. The R's would also cancel out. We get velocity depends on the gravitational constant, the radius the satellite is at, and the mass of the Earth. So for every one altitude or radius that the satellite is at, there can only be one speed that it's traveling at. If it starts to lose speed for any reason whatsoever, it will decrease in altitude. In order to experience weightlessness, you need to be accelerating at the same amount that gravity is. In this case, for us on Earth, it's little g. For example, if you're in an elevator and the cord gets cut and you are in free fall falling down, you are weightless or experience that weightlessness because there is no normal force to balance you out being pushed up on you from the floor of that elevator. A satellite is also in free fall. As it moves along, it is falling towards Earth, as I mentioned before, but the velocity keeps propelling it in that circular path. The centripetal force, once again, is provided by gravity. Here's a little diagram showing the moon as it orbits around the Earth. If there was no force of gravity, the moon would continue on in a straight line, and due to the force of gravity, the moon follows that curved path where it drops a little bit or moves downward as it falls towards Earth. Because it has such a rapid velocity, it is going to continue moving in that straight line while falling towards Earth and therefore moving in a circular path. This brings us to the cool science fiction aspect of circular motion and gravity. Perhaps in your life you've seen the idea of a spacecraft that rotates and provides an artificial gravity. This is due to the centripetal force. In this case, the big thing here is to make sure that the force is equally applied throughout your body. So that means you have to have a circle large enough so that your head and feet would have both the same acceleration. Here we have another example similar to the water cup magic. As the biker enters this loop-de-loop, the normal force, providing that centripetal acceleration, needs to be twice the weight. As it moves around, the normal force will decrease until it reaches the top of the loop-de-loop, and at this point, the centripetal force is equal to the weight, and they're in the same direction. And then as the object, or biker in this case, continues to move down, now it's probably going to actually be slowing down a little bit, and the normal force, again directed inwards towards the center, it's increasing as the biker comes down towards the bottom of the loop. I hope you enjoyed this one and my quick video on the water cup, spinny little magic thingy, bobber, whatever it was. Enjoy, have a good weekend, or good afternoon, and make sure to answer the questions.